Okay, now we want to talk about regulating fluid balance. How do we control it? So some of the common things are, right, we have ideas of like how we can drink and how we increase fluid. But what we also want to talk about is how our body controls whether we're going to have, how it controls the fluid that we have. So things to remember. So whenever you drink or you increase your fluid, you're going to increase your blood volume. And if you increase blood volume, the blood pressure is going to increase. It can also decrease the osmolarity of our blood, right? Because that makes sense. You're putting more water into something and you're not changing the amount of dissolved substances in there. Okay, now fluid output decreases our blood volume, and that makes sense, right? So we're losing water, we're going to decrease our blood pressure, and if we lose water, the osmolarity may go up. Okay, so those are just kind of basic things that we need to go over and make sure that it makes sense. Okay, now the way that we regulate how much fluid comes in is with our hypothalamus. Okay, so we have a thirst center in our hypothalamus. The thirst center is what triggers whether we are thirsty or not. So it's pretty straightforward, or logical, maybe not straightforward, but logical. What turns on the thirst center are the following stimuli. So if you don't have enough saliva in your mouth, so if your mouth feels dry, that turns on the thirst center, and that's going to trigger us to drink. Okay, so when you drink, you increase your blood volume and increase your blood pressure. Okay, now, if our blood osmolarity goes up, okay, so if you become dehydrated, the blood osmolarity goes up, your posterior pituitary is going to be stimulated, and we're going to release antidiuretic hormone. Okay, antidiuretic. So think about it. So what does a diuretic do? So a diuretic makes you pee, makes you urinate. Okay, so what would antidiuretic do? Antidiuretic is going to trigger you to cause you to hold on to your urine. Okay, so hold on to urine. Okay, so if we hold on to it, that's going to increase, right, blood volume and increase blood pressure. Okay, now decrease blood pressure. Okay, it's going to stimulate the renin-angiotensin 2 pathway. Okay, now all of these things, okay, can stimulate the thirst center. So increased blood osmolarity, okay, antidiuretic hormone, and angiotensin 2 all are going to stimulate us to drink. Okay, I want to make sure that's everything I wanted to say on there. I think that's right. Okay, so right here is this is an oldie but a goodie. This is an older picture, but it explains what happens. Okay, so here's our person in the desert. Okay, so if you're dehydrated, here are two different things that are going to happen. Okay, so you're losing water. So your blood osmolarity is going to go up. Okay, and what will happen is you'll be stimulated to release antidiuretic hormone. Okay, antidiuretic hormone is going to do a couple things. So one, it's going to stimulate your thirst center, and you're going to want to drink. So you get your water bottle and you start drinking, and it makes me thirsty talking about it. Okay, now, so you get thirsty. Okay, now, if we go down a different path, which is probably occurring at exactly the same time, okay, our blood pressure goes down. Okay, when our blood pressure goes down, kidneys release renin, that goes through all of its pathways and it gets converted to angiotensin 2, and that stimulates the thirst center, okay, as well. So it being dehydrated, it's going to make your mouth dry. Okay, thirst. So we start drinking. Okay, what part of the brain was that? It was the hypothalamus. Okay, so we start drinking water. When we drink water, the mouth is cooled and it's moistened. And then there are actually studies about cold water and warm water. Okay, so supposedly cold water quenches your first thirst faster, but but warm water, it does physiologically, it does the same thing. Okay, so then your blood gets rehydrated. So what's going to happen? Your blood volume will go up, right? And your blood pressure should stabilize. Okay, then the stomach actually gets stretched when you drink. And that actually is a trigger to say, oh, you're not thirsty anymore. Okay, so that tells you can slow down drinking. Okay, then what will happen for long-term inhibition is the blood gets rehydrated and the blood pressure goes back up. Okay, so it all kind of makes sense. Okay, now to turn off the thirst center, how do we turn it off? Okay, is we have more saliva in our mouth, so then that signal's not being sent. The stomach is stretched, so it feels full. Osmolarity of the blood goes down, and then blood pressure goes up. So that turns off the thirst center. Okay, now regulation of output. The only way we can control what goes out is to vary urine volume. Okay, so the only way we can control it is through urine, and we can alter that with hormones, and the next section will be hormones.